Okay, so I thought I would show a real quick review on how to get the information that I want from the reaction time demo. So here I have a data set from, just one of the groups. The first thing I want is a histogram. So to do that, you're going to select your data. Now you might have more than one column of data. If you measured your team members separately, then you would select each of those columns. But here they wanted to compare their whole group against a global average of, I think it was 273 milliseconds, something like that. So for this gram, we're going to select that. We're going to go to Insert, Chart, and then we're going to change the kind of chart to histogram, which is down here in Other. And then we need to fix the labels on these. So first thing, the title is okay. We don't normally put units in the title. We just do put whatever we need to distinguish the purpose of the experiment. So here's reaction time. That's not a great title, but it will do. The horizontal axis, I got those backwards. I'll fix that in a second. The horizontal axis is the actual amount of time in milliseconds. The vertical axis is the frequency. So that's how many times each range of reaction time was encountered. And then the chart title is the thing I was trying to change to reaction time. Okay. The other thing I want to change is to get a better shape of the graph. I'm going to change to 25. So these bins are now 25 milliseconds apart. You can just fiddle around with it until you find a number that you think looks good for your data. 15 looks too sparse, right? There's like extra spaces in there. 20 is probably okay. 20 actually looks pretty good. I'm going to go ahead and leave it at 25 because that's what I did earlier. Okay, so the next things we need are a measure of the average and then a measure of the width. So to do that, to get the average, there's a bunch of different ways. One way is to select the column and then down here in the corner, mine already says average because I changed it earlier, but you can select whichever of these you want. So our average is 260, it said before it disappeared. If you want the median, if your data is kind of like this one skewed towards the right, you might want to use the median as a better representation of where this peak is. One way you can do that, select the column and then go to Data, Column Stats, and scroll down and it tells you a bunch of things, including the average, which we just had. I guess I rounded the average wrong, actually. Should be 261, I guess. But 361. What's going on here? Do this again. I think I typed in the wrong thing. Yeah, so 361 for the average and 341 for the median. 361 and 341. Okay, and these are also in millisecond. I'm going to make a big deal about units in this course. So let's make sure that we have units for these terms. Then to get the standard deviation, the way I'm going to tell you is to hit enter and then start typing stdev and you'll see these options come up. We want the one with the S. And then we want to select all of our data points. And it will give us a measure of the standard deviation. Now remember, the thing we want to compare is our center value, which is usually going to be the mean. But in this example, you could choose the median if you think that's more reasonable. Our center value to our test value, we're going to compare it versus the error bars of our measured value. our error bars, so the standard error of the mean, we get, oops, ignore that. Standard error of the mean, we get by taking the standard deviation, dividing by the square root of the number of trials. If you count these, get 28 trials, and then we minus 1. So the number of trials minus 1 inside the square root. And so we get this standard error of the mean. And we can round that so that we get either 1 sig fig, or the exception is if the first digit is 1, you can keep 1 extra sig fig. So you could report our value as probably the way I would do it in this specific case is that the reaction time of our students is 341 milliseconds, and then plus minus plus slash minus 13. We don't have to put milliseconds twice, so I'm just going to put the milliseconds out here. Okay. And then we're going to compare by looking at the maximum of this, so 341 plus 2 times 13. So this is the maximum that would be in our range, and our minimum would be 341 minus 2 times 13. And if 273 is inside this range, then we can say that it is consistent with our data. 273 would be consistent with our data. But you can see it's outside of this range, and so 273 is significantly different than our student values. So here I used 2 times the standard error. Right? If we had some error bars for this value, let's say that we knew, I'm going to get rid of this for right now, if we knew that it was really 273 plus or minus 50, but that would be bad sig fig keeping. Let's do milliseconds. Then we would look at the range of this one, adding and subtracting 1 error bar, one uncertainty. So we'd add 50 and get 320, and we'd subtract 50 and get 220. And this is the range that we would compare for the target, I guess you'd say. And then for our value, you would only do, instead of doing 2 times, you would only compare 1. There is a more precise way to do this, and that has to do with pooling the variances between these two. I'm not going to make you do that. This is just a way that we can do this. So if we look at our test values, our experimental values, we see a range of 354 to 328. We compare that to the range of the target from 220 to 320. And if there's an overlap, we can say they are consistent. In this case, kind of unfortunately, it's just barely not overlapping, right? So 320 is still below our lowest value here of 328. So honestly, statistics, when they get to this fuzzy edge, you have to make some reasonable assumptions. And if you want to be super precise, there are ways to do it with like t-tests and stuff like that. But you're still going to have to make a call about, how good your p-values are and everything. So in this example, I guess I would say that our student's value is nearly consistent with the target value. Okay, So that should get you what you need. I'm going to ask for your spreadsheet and then a conclusion from the spreadsheet. Basically, I will want you to have a hypothesis. Actually, I'll make it a combination of the Canvas assignment and turn in the spreadsheet. And in the assignment, I'll ask you for a hypothesis and then the values you're comparing against, your mean and standard deviation and standard error of the mean, and then finally, what conclusion you drew. Okay, thanks.